So Europa is constantly being stretched and squeezed, stretched and squeezed. And you can see how this rubber ball gets warmer as I squeeze it. Scientists believe that the friction caused by the tidal flexing of the entire moon can generate enough heat to keep the ocean liquid. This effect gets stronger the closer you get to Jupiter, which is why Io is so volcanically active. So you can see this ball is significantly hotter now. I held onto this ball at the same time to make sure it wasn't just the heat coming in from my hand.
What sort of temperature of the ocean are we thinking?
So it depends on how salty it is. So melting temperature of ice, or maybe depressed by 10 degrees Celsius below that if it's a very salty ocean, similar to cold oceans on Earth.
And how would the flexing differ if there's this big liquid ocean versus if there's no ocean there?
If there's no ocean, Europa should flex by only about 1 meter in amplitude. But if there's an ocean in there, then it flexes with an amplitude of 30 meters. So that's an enormous deflection, and that will come out pretty clearly in the gravity data. Another argument for how thick the ice shell is, we see these very strange features on the surface that are arcuate in shape, but like multiple arcs put together. We call them cycloids, and not something you'd expect to see on an icy moon. And we think they form if a crack propagates at just the right speed, about the speed someone would walk, and is following the changing stress field of Europa being squeezed as it orbits around Jupiter. And if there were no ocean down there, there wouldn't be enough of an amplitude of that motion to explain the cracking. But if there is an ocean, then it could explain the cracking.
All that tidal flexing pushes magma in the outer core up, closer to the seafloor. Water flowing through the crust above it is heated and it picks up minerals from the ground, ejecting them into the ocean. This creates hydrothermal vents.